Hello everybody, welcome back to the Gregorius Maths video. This is the final maths video in the advent calendar, and I'm going to be using it to talk about the first isomorphism theorem. So, the first sorry, no I'm not, that's a lie. I'm going to be talking about the third isomorphism theorem. So, the third isomorphism theorem tells us that if we have, some subgroups A and B in C, then we have that C mod A, or I should probably say normal subgroups, quotiented out by B mod A is isomorphic to the quotient C mod B. Basically, like, you can think of it as like, cancelling out the A. Well, you shouldn't think of it like that, but that's the third isomorphism theorem is telling us that in this case we can just like cancel. So that's the statement that we want to prove, and the lemma that we want to use to prove it is the 9 lemma, which tells us that if we have a bunch of short exact sequences, hold on, if we have some short exact sequences like this, so we have 3 of them, like this, and we also have them going across like this in the rows. So we have like this. I'm trying to draw this as quickly as possible for the entertainment of the fans. So if we have a commutative diagram in which all of the columns are exact and the bottom 2 rows are exact, then we also can deduce that the top row is exact. And another statement which you can say is, if all the columns are exact and the top 2 rows are exact, then the bottom one is exact too. Actually, that's the one we're going to be using. Is that if you have the top 2 rows are exact and all the columns are exact, then the bottom one must be exact. We're going to be taking this as given, and we're going to show using this that the third isomorphism theorem is true. And so therefore one can, in a sense, say that the 9 lemma generalizes the third isomorphism theorem. Okay, so what this really boils down to is considering the right diagram here. So, since we need quotients C mod A and B mod A, it would be nice to consider, sort of some of the more natural, or just, natural canonical exact sequences that you get from, and not natural in any mathematical sense, just, let me just, okay, anyway. So what I'm talking about is, since A is a subset of B, or a normal subgroup, I should say, of B, we have an exact sequence from 0, A, B, into B mod A, like so. We have an exact sequence like that. We also have an exact sequence in the exact same way, like this. And so, yeah, okay. Let's see. So we already have a couple of rows that we should probably be considering. I don't need to add these arrows in here. And that everything commutes here pretty trivially. So what should the bottom row be? Well, we want to show that this is true right here. So we want really like a short exact sequence where we have this term, and it's surrounded by zeros. So, well, this term here we can easily get along this column. So we have C mod B, and again we go into 0. And this term here comes from just doing, again, this is sort of an inclusion. So again, we can just do C mod A modded out by B mod A, and we're all fine still, into 0. Then go into 0 here. We'll just send this guy into 0, which we're allowed to do because this is just the identity, which has 0 kernel. 0 kernel, so exactness is fine. And so now we've already filled out our diagram. So let's take a look. I don't know why I put this 0 in here. Let's take a look at what we have. Well, this row is exact, this row is exact, this column is exact, this column is exact, and this column is exact. So we're in a perfect position to use the 9 lemma, so we have a short exact sequence along this row, but because, hold on, the image of this is equal to the kernel of this, so it means the kernel of this is 0, aka this is injective. But we also have that the image of this is equal to the kernel of this, but the kernel of this is just the whole thing. So it's also a surjection, and so it must be isomorphism, and so we have to conclude that the third isomorphism theorem is true. And there you go. Yeah, so yeah, that's the conclusion to the mathematical bit of the Advent calendar. And all I can say is stay tuned for tomorrow. And yeah, since I've done videos in recent times about the first and the third isomorphism theorem, it is only right that I should make one on the second isomorphism theorem. So at some point that will come. And but yeah, until next time, I'll see you tomorrow. Yeah, see you then.